Hello, everyone present. A very good evening to everyone. We'll be starting in about 5 minutes. Let's wait for a few more people to join. Cool. So thanks for your patience, everyone. We'll be starting in a few moments. Meanwhile, I'll take my time to introduce to you our first speaker for the day, Mr. Samuel Kopp. He's joining us from Thailand right now, if I'm not mistaken. He's currently an AI ML engineer from the Standard Bank Group. He's also an entrepreneur working on Neurision Labs. He's already worked on a plethora of fields in machine learning, including reinforcement learning for robotics, some studies in renewable energy forecasting, and so on. He did his bachelor's in mathematics and computer science from the Monash University, and his bachelor's in AI and machine learning from the Maastricht University. I hope I'm pronouncing it correctly. So he'll start off today's presentation and tell us quite a lot of interesting things about algorithmic art, some specific algorithms. And he's also done some really amazing work on the Celtic knotworks. So some of the stuff which was there in today's post regarding the session was actually from that specific paper. So over to Mr. Samuel now.
Thank you, Yatindra. Thanks for inviting me, and I feel very honored to be speaking today in front of such talented people at Kharagpur. Yes, I'm currently in India. As you said, I work as an AI ML engineer with my consultancy, Neurision Labs. And in the past, I have done some work on algorithmic art. I would say I'm a hobby digital artist, and Pranoy has invited me to share some of my experience with it today. I hope you will enjoy the slideshow that I prepared for you. It's a bit different to the neural art stuff that you have seen before, probably. Algorithmic art is a bit more deterministic and more basic math, let's say, than basic math and basic coding compared to machine learning and neural networks. But I hope you will enjoy it, and perhaps it's an inspiration for you. So let me just pull up that presentation. All right. So algorithmic art, I don't know the exact definition of algorithmic art. You might also call it procedural art or computational art. I think what is important is that it contains in some form math and geometry. It should contain some sort of repetition and patterns. And it can be generative, so it can be generated by a computer program, but it can also be, and has been for the most time in history, been instructive. So an algorithm doesn't have to be executed by a computer. It can also be executed by a painter or someone who weaves. So let's start with the slideshow. I think the reason why algorithmic or geometric or mathematical art is so interesting is because the symmetry and the repetitive patterns, they please the human visual system, because we sort of co-evolved seeing all of those patterns in nature. So when we do something, when we play around and create art with mathematics, it's just something that we would see in everyday life, because nature creates it naturally. As you can see here, some tessellations of honeycombs, which are almost perfectly designed, or patterns on animals that actually are like tilings on a floor, if you think about it, or fractals of a leaf or another plant. I'm sure as many people are computer scientists here, you know this, or you have noticed that this art is all around us. But also since beginning of human history, we find this kind of art in cultures, in religions, but also in day-to-day skills like weaving. So on this slide here, you can see many Islamic art patterns, especially. So these star patterns, they are actually, today there's a mathematical name from how they are derived. They are Penrose tilings, and people have found this beautiful pattern before and constructed algorithms to paint those. On the right side, you can see something that's actually in India. I think it's in Uttar Pradesh. It's that star, that tessellation with those stars. That is sort of a window. And on the top left, you can see a Nordic, so European art, Celtic art, which uses a lot of interlacements and knotworks, which is actually also created by an algorithm. So let's come to the first part that I find is a very useful tool in the toolbox of a algorithmic artist, and that is tessellations and tilings. If you don't know what a tessellation or a tiling is, it's basically you have a surface and you try to fill the whole surface with some geometrical shape. And if it's always the same shape, then it's a tiling. And if the shape can vary, then it's a tessellation. So I want to show you this here. This is from the famous Dutch artist Escher. That is a tiling, actually, because it's the same geometrical form over and over, a fish, and it fills off the whole surface. You can create this by an algorithm, and there's actually a mathematical formulation for this sort of procedure. This is a Penrose tiling named after the famous physicist, sometimes mathematician, Roger Penrose. And on this side, you can see a mosaic. A mosaic is also a kind of a tiling. It's I think mosaics are done often more creatively, or with more, let's say, with more randomness involved. And on the left side, you can see something computer generated. that is a picture of a landscape, and the digital artist used Delaunay triangulation. I will come to that later. It's a computational geometry technique to create a tessellation out of this landscape. To generate tessellations, there are many different ways to do that. I will tell you how I did it most of the time and how it's done often. You should know about two concepts for that that are often used in computational geometry, and this is Voronoi tessellation and Delaunay triangulation. That's what you saw in the image before. So a Voronoi tessellation is basically you have a point cloud, a set of points, and you try to create cells around those points as if you would try to expand cells until they find an equilibrium. That technique is often used to create triangular meshes and computer graphics. And if you use those techniques from computer graphics, you can also combine those triangles to make quadrilaterals or other geometric shapes, and then suddenly you would get a tessellation. There are you will find online, you will find programs for that, and perhaps also plugins for some art software to do that, where you can either define a tessellation basically based on some parameters. On the right, you see an example. I found it in an online program. You can create an artwork out of tessellation. The next part that actually doesn't seem at the first, if you think about it first, it doesn't look like an algorithm because it looks so complex and sometimes not so geometric, but it's actually something that's mathematically defined and very related to tessellations, and that's interlacements or knotworks. So it's basically knots, making art out of knots or out of weaving interlacements. There are many examples of that type of art. As I showed you before, there are these Celtic knots in the Nordic culture. They have a specific pattern, and that pattern you find also in other cultures. It's basically the knot pattern goes once up, then once down, once up, once down, and it is a complete knot. So if you would pull that knot, it would actually create a rigid structure. It must have been very difficult for people 1,000 years ago to create those paintings, because some of those paintings, for example, on the right corner here down, that's an extract from a book. I forgot the exact name. The Gospel of some very old book from Ireland or England, if I'm not mistaken. And almost every letter in that book, or at least the first letters, are intricately decorated with those Celtic knotworks. And somebody must have developed an algorithm back then to design those, because if you would just try to start drawing, you would quickly make mistakes in generating these knots, and they wouldn't be complete. And we actually know for sure that they have used an algorithm for that we can today replicate to generate knotworks on a computer. So here you see some examples done in Blender. Blender is a three-dimensional, a 3D image generation, no, a 3D generation program. You can code in it and create structures. That for example here, it's a perfect knot weaved over. Not exactly sure what it is. Some sort of mascot. And that picture here of a shawl, that is actually not a picture. It's also computer generated. And yeah, you would think, is that art? Well, it is a repetitive pattern, and probably somebody thought about the aesthetic aspect of it too. So this was also generated with an algorithm, the same algorithm that was used for this. For this here, but on a computer. Here you see an example of Islamic star patterns, and that's the endless knot, as you probably know. It's a common symbol in Buddhism and Hinduism, Jainism, and it's has the same knot structure as those Celtic knots. Let me show you how you can make a program to generate knot work. So actually, a knot is perfectly defined with a mesh or a tessellation. So here you have the smallest possible mesh. That's just a triangle. And if you take the middle of each edge, you can fold a knot over it. And the algorithm is basically go from one edge to the next edge, or choose one randomly, and go up, and then at the next one go down, or first, follow this, and then in the end interlace them up and down alternatingly. And that works for any mesh, and you will get a perfect knot. So it's a pretty simple algorithm, actually. Here you see an example of how this is created from a mesh. That mesh here in 3D, that knot work in 3D, is actually done from the Penrose tiling that we saw before, from this year. So if you try to code this, perhaps you can find very cool mesh structures where you can discover what kind of knots those will generate. They can look sometimes very beautiful when you, let's say you have some mesh like structure that already looks beautiful. The knot will look completely different, but also very interesting. This on the right hand side is a program that I wrote. It basically works like that. You take an image of any object, and it will segment that object using computer vision. So in that case, it was like a tree of life. It segments it, and then it creates a tessellation like this over it. It tries to make the tessellation sort of symmetric. Put a little bit of randomness in there, and then it uses this knot work algorithm, and voila, we get a knot work out of that image, out of that shape. You can create better segmentation algorithms, and you can use it also on faces, on people, and so on. You can replace the knots with using instead not threads, but you can paint other geometrical structures that are like an interlacement, like those Islamic star patterns. And let's see, maybe you can create something really cool. Another part that is algorithmic art are fractals. Fractals are actually an algorithm. It's self-replicating structure, and it's mathematically defined algorithm. Here on the left top you see a fractal tree, and here you see computer generated images. On the left side, it's actually a Hindu temple. Some temples, apparently I didn't know that, are built in a fractal like form. So I find that really cool. That's a historical art, fractal art. That is done with a program that you can find on the internet and download for free, I think. It's called Mandelbrot 3B. That is a computer-generated island. That's actually the Mandelbrot set, a fractal. And this fractal is created from my favorite screensaver program, Electric Sheep. It always creates a new fractal using an evolutionary algorithm to select the best fractals. So also very cool. And you can do that with code. I think with just instructions, it works also to paint, as you can see. If you want to make very intricate things, you need to use code for that. Tools for artists. Well, to make algorithmic art, you can either physically execute instructions like paint, craft, or weave stuff, but I think you're more interested in using code. So I recommend using Python or C++ for that. Or if you use 3 dimensions, Blender, or if you want to do it on a website, perhaps JavaScript. Another way is you can build a specific software, or you can find a specific software that has already created for your purpose online. For example, there are many Celtic knot generators that you can find, also tiling generators that you can find online. And there you can just enter parameters and definitions, and you can use it in your toolbox as a digital artist. But that's not always easy if you want to combine this with another piece of art, with another part of your art work. So if you're lucky, you will find also in your image editing software or digital art software some inbuilt algorithmic art tools. If not, perhaps you can make them if they're open source, like in GIMP. Photoshop probably also has some plugins to create fractals and so on. And if not, I encourage everyone to create their own algorithmic art software. That's my short slideshow. I hope you enjoyed it, and I hope you find some inspiration. There are, of course, many other geometric, mathematical techniques of doing algorithmic art. I think those 3 are the most important ones, and I hope they help you create cool artworks in the future. Thank you.
Cool. That was one interesting presentation on algorithmic art. Does anyone have any questions, or does anyone want to discuss anything? If you want to discuss anything, you can sort of also use the chat.
By the way, if anybody does work like this and want to send me what they have or want to collaborate on something, I'm happy to do that. Just send Prannoy an email. Happy to collaborate on anything. And also, if you find other examples of algorithmic art that I didn't find from India specifically, I would be very interested. Thank you.
Cool, guys. That was one nice invitation. I think there are no questions per se. Please do reach out to Mr. Samuel, and to reach out to him via Pranav, please contact me. I'll get you Pranav's contact, if Pranav's contact, if you don't have it already. He was one of our presenters yesterday. So moving on with the session, I think we can move ahead with the next speaker in line. We have with us Mr. Sagar, who is also an alumnus of IIT Kharagpur. He did his bachelor's as well as master's here from KGP, and he's currently a senior graphics engineer at ShareChat. He previously worked at Qualcomm. He's also worked on virtual reality technologies at Viz Experts. And yep, I think we'll be getting to know a lot about simulators and how AI is being used in simulators and generating data, and how all of that plays into virtual realities, and also into how games are made, game engines and all of that. So I think over to Sagar now.
Yeah. Hi, Yatin. Are you able to hear me?
Yep, Saga, you're visible as well as audible.
Okay. Okay. First of all, thanks KDAG and Pranay for having me on board. It's an honor to be here back speaking to IIT Kharagpur students. I graduated in 2017 uh, and I was working with Viz Experts, as Yatin mentioned. I was working there for I think 1.5 year, 2 years as a VR game developer. So I got to work on a lot of VR simulations, mostly using C++ and Unreal Engine. And then later on, I like at Qualcomm also I was working on VR AR. So at Viz Experts, I was developing applications, but then later on, I started diving into research and development of virtual reality cloud gaming applications. Right now, I'm at ShareChat, again developing their graphics engine. And what I'm going to present today will be a bit different from what you guys have already heard. Like you have speakers who have already spoken about algorithmic art. My presentation is more going to be around game simulators, a bit about AI and how things are right now in the market and how the market will grow and what kind of opportunities you guys will have in the future. So let me just share my screen. Yeah, I hope the screen is visible. Uh, can somebody just let me know if the screen is visible? Hello? Yatin,
Yes.
can you let? Yeah.
The screen is visible.
Okay, you can see the presentation, right?
Yep.
Yes, sir, it's visible.
Yeah. So I want to divide this presentation into three parts. The first one being the future of compute. What like the devices that we use currently for compute and how they are going to change in the future, what kind of changes will happen and where the industry is moving. So I actually wanted to go over how games are developed, and I found a very interesting graph which actually describes the whole gaming industry. So in 1970s we had arcade. We started with mainframe computers. So as the computation started to grow, like we were able to compute more things on a computer. There were some scientists who were more interested on the visual part of it, and they started developing applications around that. And that is when we started to develop arcade games. So the whole gaming industry so far you can see is divided into cloud gaming, VR, handheld, mobile, PC, arcade, and console. So in the initial few years, we didn't have any of the other industries. We just had arcade. So yeah, as the industry progressed, then came games like Pac-Man. Then came companies like Sega, Nintendo, and Atari. Those companies then developed their own gaming consoles. So initially, people used to go to gaming cafes, arcade cafes, and then play games with their families. And then later on, as companies developed their own home consoles and PCs, the arcade market started going a bit down, and people started playing games at their own homes, right? People used to have consoles at their homes. So and at the same time we also started to see that handheld mobile devices also started growing. So Nintendo Game Boy, I'm sure everyone has played one of these in our childhood, like a version of these. And then games like Doom came up, and then in 1997 Nokia released their cell phone which had a snake game. So that was the first one of the first consumer mobile games which was developed. And then as Apple developed their iPhone, then we started to see a very large boost in the gaming market. So as of now, we see that there's no arcade market. There are no arcade cafes, maybe a few that you can count on your fingertips. And then you have a console market, you have a PC market, but you have a huge mobile market. right? This I think everyone is aware of. What I want to focus on is this particular area, right? So what is happening in the industry? So in 2014, Facebook acquired Oculus, right? And in this year, I think this year or last year, Facebook started rebranding themselves as Meta. Why does a huge $1 billion giant want to suddenly convert to a different business model? What is happening? Why are they doing this? Like, I agree, having one division which works on virtual reality, augmented reality is fine, but why does a company completely shift its target, right? So Facebook acquired Oculus in 2014 for $2 billion, and right now, after 6 years of research, they have converted themselves to a metaverse company, a company that works continuously on VR and AR devices. They even named this Oculus division to Facebook Reality Labs, which is the core division of Facebook. The CTO of Facebook, who was initially a social media person, right now the CTO of Facebook is the head of their VR AR department. So this was in 2014. Last year, Take-Two Interactive acquired Zynga for $12 billion, and this year Microsoft acquired Activision and Blizzard Studios for $68 billion. That is a huge amount of money. Oh, why are all these things happening suddenly? Why is Microsoft paying so $70 billion to acquire a gaming company? Why are there no other applications? Why is Facebook turning to games? It's because of this particular corner that we talked about, right? So right now in 2020, gaming has generated $165 billion, and it is already a largest and it already has a largest market share in the entertainment industry. And VR and AR and cloud gaming have not even started properly. So if you see this graph which I had shown before, you can see mobile gaming as this, and cloud and VR is just here. It's just getting started, not even started properly, right? So this is where the whole opportunity lies. And with these things happening, all the companies are pushing towards this particular goal of growing this area, and this is soon going to explode. There are going to be multiple jobs which will be specific to VR AR development, which will have specific AI related use cases in VR and AR in cloud gaming. And when is this explosion going to happen? This will happen when we have consumer devices. This will happen when we have 5G. So why am I saying that 5G, when 5G will come, these things will happen? Is because, like, let's imagine what our future will be like, right? Right now, if I have to make a phone call, I pick up my phone, I dial a number, and I get a phone call. I talk to my friend. If I have to watch my news, I do that on one screen. If I have to watch any movie, I do that on one screen, right? Now what if we are not limited by screens? What if we are not limited by the screens, and what if the things that we are interacting with are already there in our surroundings? Right. So this is the end goal which companies like Facebook, Microsoft, Qualcomm, everyone is pushing. So Facebook has their headset. In the picture, what you are seeing is Oculus Quest 2. So this is their flagship consumer headset. Its price is less than a OnePlus device, right? It's less than $30,000, 30,000 Indian rupees in the US, and it already has capabilities which are like which were unimaginable a few years back, right? So in Oculus Quest, you don't even have to use a controller. You can just use your hand gestures. So HoloLens 2 also allows the same thing. If I don't know if you have used it, there's a, like, I started my journey with IIT Kharagpur's industrial engineering has a very good virtual reality lab. I think computer science department also collaborates with that. So if the students are like interested in this, you can go visit industrial engineering's VR lab and take up some project and try to do something, but you'll get to experience these things there. I started my journey from there. So these devices already have like voice-based inputs and gesture-based inputs. You just have to pinch. You just have to pinch and drag a window. Like let's imagine a case. I have to book an Uber. What is the procedure? I pick up my phone. I put the drop location. I book my Uber, and then I wait. I wait for the driver. I wait for where he is. I see the map continuously. Imagine that same thing in AR now. Now you are wearing a AR headset, right? AR glasses, and you are standing in your balcony and you are waiting for Uber. You're not watching your phone, and the driver's location is geotagged and it's visible. It's visible directly on the road. Like if the driver is standing 3 lanes away from me, right, and that lane is not visible, I can just see a pop-up, just like you see in your phone a notification bar. I can see that notification in the real world. So examples like this are like where we are headed. Qualcomm is building chips for AR VR devices. I was working on a software on the software stack of these devices. Oculus is pushing Facebook Oculus is pushing that way. Microsoft is pushing that way. So the industry is going that side. And since after COVID, like COVID has changed things for all of us, and all the companies are working remotely. Even billion-dollar companies are now functioning from their homes. So people have realized that yeah, things are going to work well even if you are not in the office. And so what are more mediums of interaction, right? How can you be more close to your colleagues? How can you work together without just talking to a screen? You can talk to a real person like that. So these things are already there. They are not in the mainstream. There are devices. Things are growing. As I said, right, this market is just growing. So there are large number of opportunities that will pop up. And yeah, and let's talk about how this process will work, right? How is this different from regular computing? So whenever, like, my phone is heavy, right? My phone has a battery inside it. It has a processor inside it, and it is heavy. Now imagine putting this phone on top of your head, right? It's not possible to wear this a device which is this heavy on your head all the time, right? You'll get nauseated. You'll have problems of, like, you cannot hold a heavy device on your head. You want something that is very light, right? And to make things very light, everybody wants to push things on the cloud. So the compute will happen on the cloud, right? While playing a game, what happens? Why I type some word, my character in the game does something, and then the CPU tells the GPU what to draw, and then GPU draws that on my screen, right? And that is how I see my character moving. Now, in case of VR and AR devices, imagine a very small device which has a very small battery and which is just a display. It doesn't do any kind of compute. So where is this compute happening? This compute will happen on the cloud, right? So all the companies are like pushing their way, and they are trying to build applications which will be cloud supported, which will render things on the cloud, and your phone or your glasses will just be a display. So all the major players in the market, they are predicting that we won't have smartphones after 10 years. Like, you won't see any touchscreen smartphones. You will have glasses, you'll have headsets, and smartphones, even if you have them, they'll just be an add-on, right? And the question is now, since we are talking about AI, right, where will AI be used in this step? You guys are trying to learn about AI. And the answer is that AI will be used in every step. Every step, AI will improve things. Right now, where is AI being used? So these are few of the applications, few of the things that I have like compiled down for you guys, and to understand what is going on right now. So to understand the user expressions, like, this is a project from Facebook, right? You have cameras which are pointed to your eyes, right? And those cameras will be used to capture the image of your eyes, and just from your eye image. Like, there are no other cameras capturing the mouth or head or hairs, nothing. Just from from your eyes, the AI algorithm predicts what the expression of the rest of the face is. So to understand the user expression, to replicate that user expression into the virtual world, AI will be used. Next application is to understand the world around us, right? So this is a very interesting paper which is called Nerve. You can have a look at it. It's available online. So what this does is it takes just a few images. Like, if I have to recreate my whole room, I'll just record it using a few images. I'll just take 5-6 pictures, and I'll send that to that AI algorithm, and then the output of that algorithm will be a 3D model, right? So this is already there, and this is implemented and very polished, right? And this is still in research. So imagine a few years down the line, what is going to happen, right? This is one part of 3D reconstruction. Second part is spatial understanding, right? When we are able to reconstruct the whole room, now now we need to understand, like, where is my table, where's my laptop, what is a TV, what is a wall, what is a curtain. I need to understand these things. So this is where spatial understanding and object segmentation comes in, right? Now when I'm able to reconstruct my world in 3D, after that I understood the world, the third step is basically collision detection, right? I'll be able to detect where my hand is, right? So HoloLens and Oculus Quest, they already let the user type in the air. I have used it at Qualcomm, so it's very fascinating. And if you ever get a chance to use HoloLens too, I will recommend you guys just give it a try, or at least see some videos of it. You have a glass and you can type in air, and that experience is like very good. And it is just 2022. Imagine like 5 years, 10 years down the line, what things will happen. These devices which are heavy and which are on the head will get smaller. The computer will shift on the cloud. There would be more understanding of the scene around you, and it will be a seamless experience. And that's why I'm saying that smartphones will be replaced. The fourth is occlusion, which is basically like, how do I like, let's say I have a virtual cat in my room, like I have a virtual cat which is roaming in my room. Now my display should, my algorithm should understand, right, that my cat is behind my laptop. It's not in front of my laptop. So if half of the cat is behind my laptop, right, and half is visible, that rendering should happen in such a way that half of it is cut, right? So that is what is called occlusion, right? And this is where again the role of AI comes. So all these things come under spatial understanding and understanding the world around us. This is where AI is used now, is in research, and will be taken further. Then third thing is understanding user inputs in VR. So these ways are already there. These are, I'm not saying that these will be there. These are already existing techniques. This is a device called Leap Motion, and this technology is already embedded inside a lot of headsets these days. So you just need to move your hand here and there, and it will interact. It will understand what kind of movement your hand has. It will reconstruct your hand mesh, and it will allow you to pick up objects, right? And these are the ways to understand like the user input in the virtual environment. HoloLens 2 already allows user to type in there, I already told you, and you can actually have your whole desktop inside HoloLens. You can have your whole desktop. You can, let's imagine like I'm watching YouTube video now. It's not on my screen. I have pinched that YouTube video on my wall. So whenever I come here, since my device understands the scene, since my device understands where I have placed that YouTube tab, when I come back to my room, wear my glasses, it will still be there. So these things are already there, and in development, and soon will change the industry. So I think I talked a lot about what projects are there. I want to show one of the projects which I had worked on. So this is a project which I call 3D Telepresence. This was there. This was a side project which I worked at Qualcomm. So on the right side, you can see this is me sitting in that area. In front of me is a depth camera, and that depth camera captures my point cloud. It's not an image. The left side that you see, it's not an image. It's actually a 3D version of me, and it live streams that whole version. So it's movies like Star Wars and Avengers have those holograms, right? So this is a prototype of that, and just to showcase ki this was built in like I think 10 to 15 days we built this. And if like two guys can do this as a side project, you can imagine if there are like hundreds and thousands of employees who are working towards this goal, what kind of things can be accomplished and will be accomplished in the next few years. So let's just watch this project. So I'm doing a lot of motion here, and you can see that my avatar is still tracked there. I'm not leaving that sofa, right? Even in the virtual world, I'm sitting on that sofa. And this was recorded using my Android phone, right? So these possibilities are already there in our existing phones. All the noise that you see, this is all captured by the depth camera. And the plane that you are seeing, right? This is the AI algorithm actually predicts what is there in my scene. If there is a plane, it will allow me to place myself on that plane. So this is what is done here. And to conclude on part one, I said, right, there are 3 parts. To conclude on part one, like their next set of jobs have already started coming up, and There will be requirement for people who are good at programming, people who are good at math, people who are good at creativity, people who are good at understanding like these 3D algorithms and what the knowledge of like machine learning, AI, computer graphics, human computer interaction, and handling large scale data. All these things will come together, and like jobs which have a cross platform requirement, cross functionality requirement, and people with a varied skill set which have knowledge from all these things will be required in the few coming years. So this was the conclusion of first part. Let's go to part 2 of the presentation, which is 3D industry and AI. So I was there with experts developing games, and I got to understand like how games are built. I got to understand how the world is built, are built, what kind of animations are built, and how we program them, and how we ship the game. All these things I understood, and this is some part of my learning. So what does it take to build a game? This is a very rough idea of what it takes to build a game. I mean, there will be multiple processes which I have skipped, but to summarize, the first step is ideation. Obviously, you would need to understand what kind of game you are developing, what the game will be, and then designing the game. Actually, trying to understand what levels will be there in the game, what will be the difficulty of the game. The part 3 is world creation of all the assets, creation of the environment, creation of the characters, animations, then texturing, coloring those characters. Like my skin should look different than my road, my phone screen should look different in the device, my cloth should be like a cloth. All those things are defined in world creation. Actually using programming languages like C++, C# to create a relation between all these aspects of game development. And fifth is testing. So this whole process is an iterative process. It's a circle because it happens in iterations. It happens multiple times, and then it's play tested. That game is play tested, and there are multiple iterations. And it's a long process. Like to build a game, to finish, a very long process, and is a very costly process. Let's understand what it takes to build a character. Now we understood what is built. Let's take a part from it, very small part from it, and try to break it down. Now these images, let's imagine I have to build a character which is a girl, and which is a muscular girl with some boxer like position, this position. So what the artist will do, he will collect all the reference images first. He'll create all the references, and then the girl will have hair, like imagine like the girl will have hairs like this, right? And a face something like this, if I imagine it that way. And then she will have hands which are more metallic, like like a machine, right? How do we build such things? So when an artist takes these reference image, he first sketches out everything. He first sculpts the person. He creates a basic model of that person. Then he adds details, skin, hairs, imperfections to that model. Then he adds colors and materials to that model. Then he adds bones to that models, and then he animates that. And this is again an iterative process. When this iterative process is over, like let's combine these three things together, and this is what we get at the end, right? This I picked up from an artist, and he had explained his whole process. A very interesting final result of what the process of building a character is. Now see the details in this character, right? The cloth looks like a cloth. The hands look like machine hands, right? The hairs are so perfect. So to develop, and there are imperfections also, like there are drawing sketches. To develop this level of, like, all the games these days will have characters of this much detail. To develop a character with this much detail, it requires a lot of man hours. Like, this is just for a single character. Now imagine if you have to create multiple characters, you have to create a game level, you have to create game mechanics, what it takes to build a game. It takes a large amount of money. Now, since we are talking about the cost of the games, let's try to put a price tag on everything, right? So if I just take a general rate for an artist or for a programmer and try to multiply it with the number of hours, these bridges will cost me somewhere around 4,000 or $2,000 poles, right? A $6,000 car, another $6,000 car, to another $2,000 walls, $10,000 roads, $30,000 main character, right? And this is just a few objects in the scene. Now imagine what kind of cost goes inside making the whole game. This is just a part of the scene. If if I tell you like what the cost of making GTA 5 was, it was this much. It was $265 million. Imagine this much amount of money spent on making virtual things, right? There must be a smarter way to do this, right? So this is where AI comes in. Right now on the creative on the creative side, AI hasn't been able to contribute much on the game side, but it is under development. And I'm very sure like in the next 5 years, there would be advancements where AI will be used directly into developing some stuff. But I will just go over what things AI is doing right now in the gaming industry. So first thing is super resolution. This is very simple. Render your game. So if you reduce the resolution of your game, it will run faster, right? I think many of you might have observed, if your game is laggy on your laptop, just reduce the resolution. So where AI is used here is we'll render the game at 1920 cross 1080p. We'll render the game at 1080p, and then we'll send the input of the AI algorithm to render it with 4K. This is already there. This is there in many games. If you have an NVIDIA GPU, you can directly test it out inside your game. So this is one part. Why is this helpful? Again, because we are rendering at 1080p, it requires less compute than 4K, and you're upscaling it. Upscaling is a cheaper operation because you already have a trained model to do that, right? This is one part. Second part is frame rate upsampling, right? The major issue that all the gamers face is मेरा frame rate सही नहीं है, 30 FPS के नीचे जा रहा है, it's laggy. This is the main issue, right? So what the AI algorithms are used right now are like we won't render frame 1, 2, 3, 4, 5. We'll just render frame 1, frame 3, and frame 5. Then we'll interpolate frame 2 and 4, right? So this again reduces the compute. So lesser compute and more performance, and these things are already there in existing GPUs. Third thing is denoising in ray tracing. So a lot of the games will support ray tracing these days. Ray tracing, what is ray tracing? To explain in a very simple language, ray tracing is similar to how light acts in your real world. So you will have light rays coming up. These light rays will bounce here and there, and then they'll reach your eye. The same thing, same mathematics is there inside your GPU, and it is implemented. And all these rays are shot from the light source and then traced till the eye, till the camera, and that is how each pixel is colored. This is how ray tracing works, right? And now, since these black dots that you are seeing, these gaps that you are seeing, these are because we are using less number of rays. So again, how AI is used here, we will render with less number of light rays. We won't use all the light rays. We'll use very less number of light rays, and then we will tell the algorithm, yeah, just fill the gaps for me. So this is already there. Then this part is not there, generating concept art. So when you create any new game, games like Prince of Persia have beautiful worlds, right? Games like Assassin's Creed, those games have very beautiful worlds. So people will create concept art first. They'll create what kind of environment do you want. So there are like Pranoy might have shown you yesterday that there are already AI algorithms that generate that you feed a text to it and it will generate something. Now imagine an AI algorithm doing the same thing, right? If I generating this, I want an island and I want a broken I want a broken castle on top of it, and then there should be a lot of water and stones. If I just type it and let the AI algorithm give me hundreds of outputs, I can use that to generate concept art. So this process will be faster in future. Then this is again not there, but it is in progress. Then adding photorealism to the game. So this research paper, how it works is, on the right side you have a footage from GTA 5 game, and on the left side you have a realistic version of it. So this AI will take the gamified input and convert it to real input. So you will have photorealism in games in future. So this is another application. And then again, simulating physics. Simulating fluid dynamics is very difficult because it requires a lot of computation. AI will be used here too. So these are few of the applications that I wanted to show. And to conclude, like, AI will come into play in multiple levels of the 3D industry and gaming industry. Creative AI still needs some work because, but it will be there soon, right? I talked about this concept art. This is creative AI, right? So It will take some time, but it will be there. Then AI to facilitate compute is already there. Like these parts, denoising, frame rate, upsampling, resolution, super resolution, these things are already there, implemented, already there in playable games, consumer games, right? So this was part 2. Let's talk about part 3. This will be a short part, and it has some of my projects which I worked. And so currently, what is the state of current simulators? So we started with simple 2D games which were like black and white, which didn't have collision and all, which didn't have lighting, which didn't have much animations, very basic box level games in 1970s. And in 2022, today we have Unreal Engine 5. This is my favorite tool. You guys can also just go ahead and download, and this is completely free. Open source, all the code is available. You can build it from scratch. You can go download it. It has multiple sample projects which will showcase the capabilities of it. Are like it can render billion triangles at the same time. It uses all these things, whatever I had mentioned before. It uses all these things, most of the things it uses, and it is a very good simulation tool. So the current state of simulators, the left side, what you are seeing, these images, right? These images are there, like these are freely available projects on Unreal's website. This is a project called I think some city space project. It is there on Unreal Engine Marketplace. You can just go and download, and you can see how realistic it is, right? It is not a recorded or camera captured thing. It's generated from the computer, and it's generated real time. So what the difference between games and movies used to be? Like imagine a movie like Avengers. To render one frame of Avengers, it used to take them days. And to render that, they didn't have a PC. They used to have render farms. Like what is a render farm? Imagine like multiple computers stacked on top of each other, each of them working to color one pixel, right? That is how a render farm works. So that was before Unreal Engine was developed. Now Unreal Engine has such high capabilities that you can generate movie level cinematics, movie level games, just in a game engine, just on your PC, and you can do it real time. Like what I mean by real time is you can just press play and things will happen, just like a game, a movie, just like a game. So right now Unreal supports real-time global illumination. Global illumination is again ray tracing, like how light reacts in the real world the same way. Real-time physics solutions are there in Unreal Engine. Ray trace lighting, ray trace reflections. The reflections are very real, and then it also has support for multiple platforms and multiple VR devices, and it is able to render billions of triangles together. They have done a lot of optimization on this. So this is a tool which I'm not sure if you guys have seen Love, Death, Robots. It's a series on Netflix. And one of the episodes of Love, Death, Robots was made completely using Unreal Engine. Disney's series called Mandalorian, you might have heard of it. That whole series was shot using Unreal Engine. So you don't need any 3D softwares now to render. You don't need days, you don't need months. That whole cost has come down just because our simulators have become so strong at this point of time, right? How are these simulators used in AI training? Let's talk about that. So we all know, right? To train an AI, you need data. You need lot of data. If you want to train a drone, you'll have to actually provide it images of aerial images of all the landscapes, all the cities, and you'll have to label those images and then tell the algorithm that yeah, you have to move this way. But imagine if our simulators are so capable, they can render such high fidelity and such real-time physics and lighting and reflections. They can render almost like a real world. Then why can't we use these simulators to train AI, right? So that is what a lot of companies these days are doing. So this is a project from Microsoft, AirSim. So on the left side, the image, the video that you are seeing, this is a drone, which is a virtual drone, right? And this is the data. This is the depth data. This is the segmentation data. And the best part is you don't have to label it. ये सब already available है. All these things are already available because it's the world you made, right? You can program to segment things inside the world. You can tell apart what things are tree inside the virtual world. So it's easy for you to label. So many companies are using these kind of solutions, and this is also built on Unreal Engine, by the way. So many companies are using these kind of solutions to actually generate data for their AI models and then train them. So this was one part. this is how simulators are used in training AI. Second is like simulators are also used in training humans. So this is a project which I worked on. I was like one of the main programmers of this project, and this was made for DRDO, for Viz experts, and this was actually don't like the visuals are not that good because this was a project which was built on Unreal Engine 4.12, and right now we have 4. I think 4.28 is already there. Unreal Engine 5 is there. So this project was my first project. It was 5 years back, and the visual capabilities that the game engines have these days today are like very good. So what this project was DRDO, Snow and Avalanche Study Center in Chandigarh. They came to us. They came to us asking like, yeah, we want to train our soldiers. We want to tell them what kind of area, what kind of trees are there, what kind of landscape is there. How will you expect the weather to be there when you go to Siachen? So this whole mountain that you see, the trees that you see, are exactly same as what is there in the real world. You can get the whole satellite data from, like, we got the satellite data from DRDO, and then we built this solution for them where we actually placed algorithmically again placed those trees wherever that data was pointed to. We colored those landscape in the same way as it was there, and then we let the soldiers wear the VR headsets. So you can see here a soldier is wearing that VR headset and operating this guy. This guy will go around and try to perform rescue operations in a avalanche. So you can actually rate. You can before we used to have just bookish knowledge, right? We used to teach people, yeah, you have to do this process whenever somebody's stuck inside snow. You have to do this kind of process. But now you can let the users experience, let the soldiers get trained using this. So virtual reality is again used in training AI as well as like humans a lot. Game engines are used a lot there. And this is again one of the applications. If you dive deeper into what kind of things are built, you'll see that this is used in healthcare. This is used in education. This is used in factory training. This is also used in industrial robot training. So multiple applications, right? So the simulators have grown to such an extent. So to conclude, the future I think is a lot 3D. And if you guys have any questions, please shoot them at me. You can visit my website. I have other projects mentioned there. Yeah, I think that is it from me. If you guys have any questions, just let me know.
So Yatindra is having some internet issues as it said, so I will be continuing the hosting from this or from onwards. So yeah, Saga, that was a great session. Personally, like I have an interest in game development and how we can future aspects of AI in game development and stuff. I really found it really insightful, and I believe that is same for all the people present here. So if anyone have any question related to the presentation, please go ahead.
And this is again not only will be used just in games, right? Because the simulators are becoming better and better, right? So
Yes.
they will be used in real life applications.
Yes.
And they will
So
also cover the next set of applications which will come up like after you have cloud gaming and all these things enabled, right?
yes, right. Because right now I think so the only issue is that we have to wear those hardwares with us. So that's a bulk we carry. So once we are advanced that much, that whole computer can go on the cloud. So I believe that the thing will be much more advanced in the upcoming years.
Right. You guys can search for Nreal Glass, Nreal Glass. So that glass is actually of the form factor of a normal spectacle that you wear, and it is an AR headset. You can play games on it. So that is already there in the market. Consumer headset.
That's great.
Yeah.
So does anyone have any question related to presentation or any stuff related to it, or about future aspect of AI in simulations and game? You can just go ahead and ask.
Are all the attendees from IIT Kharagpur only?
I don't think so. Like most of them are, but there are lots of attendees who are from outside IIT Kharagpur, like who are really interested in GANs and creation of art from new level. So
Okay.
we are getting lots of messages from guys like the workshop is really insightful, especially the speakers, the presentation and content are really good. So that's thanks to all of you guys. The sessions are really successful. So I believe no questions are there. So moving
I
ahead.
have a question.
Okay. Go ahead, Arindam.
Hello, Sagar. I have a
Yes.
question that when we take into account the photorealism in a game, we need a
Right.
lot of real life assets in forms of photos and stuff like that to make an equivalent form of it in the games.
Right.
Uh, but but it is very difficult. For example, if we are making a game scene or maybe a chapter of the game which is totally based upon a desert or a city lifestyle, so
Right.
it is not possible to take millions of pictures of a particular city and totally replicate it. So
Right.
in making of the game assets too, is artificial intelligence is taken into account and the computer generates some form itself.
Yeah, so right now, like as I mentioned, right, in creative AI is used for, might be used for concept art recently, and there are papers like NERF which from a few images, from 2 to 3 images, you are able to generate your 3D model. Those things are there in research, right? And as those things, like I am sure, like in 2 3 years down the line, those will be there in applications actually. So that is one part. Second part is like companies like Epic Games are actually, Epic Games is the one who owns Unreal Engine, right? And games like PUBG, Fortnite, all these are made on Unreal Engine. And to add photorealism to those games, Epic Game recently bought a company called Quixel. So Quixel is a company that exactly does what you said, right? You need to capture millions of images of things, right? You need to go to a desert and capture millions of images, right? So that those things, Quixel does it. Quixel engineers, they go to a desert, they go to a landscape, random landscape, they capture all the stones there, they create a 3D model out of it, photorealistic 3D model, and that company was devoted to building those things. Now, since Unreal Engine, Epic Games is getting so much money from Fortnite, right? What they decided? They decided to acquire this company and that set their library free. So if you go to Unreal Engine's website, if you download their Quixel library, you will see all the stones, all the desert landscapes, all the mountain landscapes, and like leaves, trees, all those things are there for free. People are making movies out of it. Even the Netflix episode, right? Love, Death, Robots. They used those assets. So Netflix is not a small deal, right? It's a big deal. They will use professional assets. So those assets are of those levels. So though companies like Epic are promoting users, promoting game developers to actually use these high end assets and develop things, to answer your question.
Yeah, thanks.
Yeah.
Good. So I don't think so there are any further questions. Before moving to the next speaker, I would like to, guys, please take 5 minutes break because lots of stuff were covered in by both the speakers and there were a lot of information shared. Just take in before moving to the next speakers. Thank you, sir.
Thanks. Bye.
Bye. And I would also like to make an announcement actually. So the thing is that one of the main purpose of this workshop was to create awareness of the how art can be generated using algorithms, right? So we in KDAG are making a separate group for it, so that we can research on it and create some different models and collaborate with people who have similar interest in this stuff. So we are trying to hold an selections. The selection form will be released tomorrow, I guess, or today. Just be updated with the Facebook page for the KGP people, that is obviously. For the people who have currently finished first year and also for the second years, right? The people who have currently finished second year are going to go into third year. So it is opportunity for both the years who are interested in this stuff. So they can fill the form and obviously try for it. So that was one of the announcements. Great. So I think so we can now move forward with our session. So I would like to invite our next speaker, that is Mr. Abhishek, who is an KGP alum and who is currently working as a data scientist at Captain Fresh. He also previously worked at Just Dial, and he has worked extensively on computer vision and full stack development of data application for the Indian market. So, hello Abhishek.
Hi, bro. Am I audible?
Yep, you're audible and you're visible too.
Yeah, okay, cool. So very good evening to all of you. First of all, I like to thank Pranoy and KDAG team to allow me to deliver a presentation here. It seems always good to back at your college, even if it is virtual only. So I'm a graduate of IIT KGP from a batch of 2018. After that, I have worked for almost 4 years in Just Dial. And extensively I worked on computer vision and deep learning models, starting from training, testing, and deployment of everything. And this February, I have moved to a new startup called Captain Fresh. It's a startup founded in 2019, and I'm a core team member and delivering. I'll already in the process of delivering end-to-end projects in this team. So let's start with this presentation. I'll share. Wait. Yeah. Is it visible?
Yep, it is visible.
Okay, cool. So machine learning here. It's a big word, very interesting and hugely used word in the present world, and everyone is talking about it. But and everyone wants to be part of it. But the complexity inside a machine learning model and in this domain is very vast. We will be deep diving today in this field, and we will get a hang of the machine learning industry so that people can sort things out in their mind regarding of what, where, and hows of machine learning. So what I can say is like in the last 2 days, there are lots of things that has been taught. Sagar was there, Pranay was here. Everyone told so many specific things regarding modeling and creating random art and all the other things. So what I'm going to do is make it all sort out. So the agenda for the day is understanding a machine learning industry in India, getting the hang of data, and TLDR for students, and there will be a surprise for all of you. So hope to look forward to you all for this presentation. Let's start. So what really is machine learning? It is a science of getting computers to act without being explicitly programmed. So in other words, a machine is learning. Seems very easy, right? Like just a machine is learning, but using that, we have actually made self-driving cars, practical speech recognition that you are using every day in your phone, intelligent web search, Google, obviously, and then traffic management systems, which is not good in India at least, but elsewhere it's using AI a lot to manage the traffic. And then we have entered into finance, accounting, general management, IT operations, administration, retail, transportation. So all these fields we can use machine learning. Now, if it is easy, then how can we use all these things? So for that, I need to go back to the previous slide. If you have missed the image behind it, if you can see this image, it's like a vector space where so many points are there, which we will call data. This is a data space where so many data points are connected to so many other data points, and it's making kind of a connection or relation between each other. This is in simplest layman term, a machine learning is like you are connecting data in such a manner that you are making a like relationship type behavior for a particular problem, and then you deal with this. So in very small term, this is a machine learning in a very easy layman 5-year-old child explanation. But after that, we'll see how this simple problem can become so complex, and what are the other things in machine learning industries. We'll move forward. With the general overview of machine learning industry is we have 6.4 billion valued in 2020 around July and August, which is Indian artificial intelligence market. So this is just 2020 data, which is just started to grow. Now it is going very faster rate into 2022. Most of the companies are looking forward to hire a team or already started the job in machine learning domain to make life easier for them as their industry. So sorry. In India, AI investment in rupees 773.64 billion in 2017, and it is expected to grow at annual growth rate of 33.43% during the next 5 years of this tenure. This is almost complete now. So supposedly you can add this thing and you can actually find out what is the current value of our market is. And there are only 91,000 AI personals who are actually working in this industry. So think about you all 53 to 100 people. You will be adding to this number if you are choosing to work in the same industry, and it is not such a big number. So you can also see the average package is very high, 14.7 LPA, and you can go through your life in this machine learning field if you are willing to give yourself enough time and understanding of this concept. And there is also one more thing that government is hugely pushing in this health sector field also. So there are a mix of government plus our industry plus corporates. So everyone is now going to get intelligent. So if you look at this chart, you can see the IT services has $3,000 market, $1 million market, then goes for technology, BFSI, then engineering industries, retail market, energy mining, telecom, automotives, research, healthcare, travel, and whatnot. So the field is so vast, and almost all sectors of industries are kind of using the same thing. But as you can see, IT is at a very different level compared to all the other things. Moving on, so AI ML in technology, IT services an area. So the one I talked about, we have IT service firms, Accenture, Capgemini, IBM, software tech firms, Amazon, Google, Microsoft, Oracle, telecom firms, Nokia, AT&T, electronic firms, government firms, research firms, HAL, DRDO, ISRO. So in every field we have seen, and we can actually go and search on the internet, like what people are using, what kind of technology related to ML. And you will be very confused, if I must say, if all this industry are actually using ML, and you are as a student who only knows coding and all, how to get yourself into a field which is so confusing to you right now, possibly for many of you. So the AI market share and sizes relation to the type of companies is the highest across the board, MNC, IT, technology, and electronic categories. So as I can see, this should be a very difficult task. If I can tell, if I ask you, if you want to work in Nvidia, or if you want to work in Nokia, or you want to do some complete IT service firm in IBM, Accenture, and wanted to do modeling there and do their work, you have to learn a completely different thing than working in Nvidia, than working in Nokia. So like, everything is different, every industry is different, they are using different technologies, they are using different business models. So for all this combined effect, if I ask you how to go and enter into the machine learning field, the first question I'll ask to you guys is, what is data? Because data, machine learning is all about data. It's just like water to us, the data is for machine learning. So there are generally 4 types of data: numerical data, which you can understand 0, 1, 2, 3, 4; categorical data, which is like red, green, blue, any category. You can convert category to a numerical data, but that numerical value does not mean anything. So if you say red is 0, does not mean red is 0 in value. It's just a number. And there is time series data. So this is a very good machine learning advancement which is going on these days. This is understanding audio, understanding text files. So, and there are other seismic, other type of seismic rays or waves, all the other waves you can see, use in time series data and make predictions there. And there is this text data, which we all have seen in Google, auto suggestions and all. They are all using this kind of modeling techniques, using these 4 types of data. So depending on the type of data and nature of the problem to train, we chose from various type of machine learning models, such as classification model, regression model, LSTMs, decision trees, RNNs. So if I ask you make a classification model, you will use a categorical data. If I ask you to make a regression model, you will use a numerical data. If you are going to make some text classification or something, you will make LSTMs, decision trees, and RNNs for this time series data. So we use different modeling techniques for different kind of data. But for machine learning industry, we'll broadly classify data in 2 terms only. One is structured data, which you will find in DB. Generally, DB, as a student, people don't hear a lot, but this is a term which is very common in our industry. One should know what is a database, and one should also know how to work with the database softwares like MySQL or something. So there is structured data, and then there is unstructured data, which is like wild text, images, audios, something. So in general, structured data is easier. Artificial intelligence system model can easily understand this data and make model out of it. You can get this data from GPS sensors, online forms, network logs, web servers, OLTP systems, etc. And it is considered mostly a number values. And for unstructured data, this is a like very complex data. You need complex deep learning models to understand this kind of data. And these data generally have images, audio files, text files, video files. and you can collect this data from email PDFs, Google, anywhere, from wherever you feel like. Just the separation between structured and unstructured data makes the ML its core. So if I ask you, life after college, it will be seems like if you are working with structured data, you will be mostly doing data analyst, and you will be working as a business analyst. All these two people generally work with structured data. For an unstructured data, a data scientist is there. But it's not like a data scientist cannot work with structured data. So a data scientist can work with both of the datas. And generally, a data scientist can do machine learning engineering and can do data engineering. Now, these all the terms is in industry, but as a student, I was even not aware of what is a data engineer, what is the difference between ML engineer and data engineer, what does a data scientist do. So in a very easy diagram, this is a very nice picture where you can understand, like, a machine learning, a data scientist is generally a data engineer and a machine learning engineer. And a data scientist generally works with both kind of data. And data analyst and business analyst only works with structured data. And so, yeah. So your life after college should be a end-to-end journey. This is what I should say. So it's been like well established in machine learning that it is capable in all major sectors in the industry, and new learning is always fun when it is combined with your previous knowledge in your field. So what I'm trying to say here is, after telling you all the industries where you can work on, you can easily relate which department you are in, what kind of machine learning project you can involve in related to your department, so that you can get interest in it. You can make an end-to-end project and you can start your journey for machine learning. By end-to-end project, I mean to say you are making the project and you are delivering it also to the person who does not understand a single word of coding. So for that, you have to make a module or something out of it as a front end, so that he can see very easily. This is an end-to-end journey, and one always have to know how to do this. But to do this, you will have to do data analytics, you will have to do data engineering, you will have to do data science, and then you have to do ML engineering to finish the whole thing. So it's not like you just want to become a data engineer, or you just want to become a data scientist. If you go like this, sure, but like, it's better to work with all the things so that you get a better hang of all the fields in data science. So now to answer the most important question of this are that how to aim for a machine learning journey. So to start with, you will start with the end-to-end project. You'll start with data analysis, but it's not like exactly a data analysis, because the data analysts actually translate information into knowledge, identify trends, and use this analyzed data as a strategic engine for making better database business decisions. So generally, a data analyst does not do much with coding and all. He just sees the data, he or she just sees the data, and then later on come out with conclusion like what the data tells them. But for a data scientist, generally data analysis means that he has to gather the data and measuring information from countless different sources. So for that, you have to look for the meaning behind your project, like what kind of project you are doing, what kind of data you could need, then what kind of places where you can find this kind of data. After that, you will do data collection and you will try to find some patterns. Using that pattern, you will make a model, use some LML algorithms, and after that, you look for trends or some future changes. So you'll predict some future changes. This is how you finish it, just a data science project, but it's not even deliverable yet. You can run this on your Python software. That's it. So a predictive model is as good as the data you are gathering. So the data collection practices are crucial to developing high performance models. To be honest, in 4 years, I have worked less on coding and more on data. The more precise my data is, the better my result goes. So it's a very nice statement with my experience adding to it, that in data science, if data is not really good, if you have not spent 60% of your time or more than that in data, then there is no way you can train a best model ever, which is available in the internet with such high accuracy for your data. So the data need to be error free and contains relevant information. So for all that, what I said before, that you need to learn a web scraping tool how to download data, how to get data from the internet. Once you have this data, you will be start doing your all the other projects. So I think in data analytics part, generally it's all about what data and from where. Then we go to data engineering part, where a data engineer, what it is in professional terms, the data engineer builds and maintain the data infrastructure such as data pipelines responsible for transferring the data from different sources to one place and use the rest of the role. So in industries, data are present are in very different databases. It's a huge chunk of data and TBs of data, and for that, data engineering has to do all this thing. But as a college student, all you need to do is whatever the data you have gathered, you have to convert it in a way, in a format, so that you can use that data in your training models and all that. So as a data engineer part, what you will be doing is this thing, ETL, extract, transform, and load. So the process of extracting data from multiple sources, transforming it by business needs, and then load it to your target database. So your target database will be your laptop only, but then you will be doing kind of this ETL thing. Once you have all this data engineering require a higher understanding of this relational databases and SQL queries, because most of the data you are going to put in a SQL query. You won't be taking Excel files and keep on making your project in Excel. It will be a very good practice as a student if you start learning SQL. It's not like data scientists cannot learn SQL. You should not learn SQL, because the first thing a data scientist do is learn SQL so that they can actually fetch the data. Once they have the data, they can do all the other things. So since we are in a big data world, it is usually managed in the cloud. So we also know any one cloud, it preferably AWS, but you can, as a student, whatever you find good, Google Cloud, Azure, AWS, but look for cloud system, look for SQL, and then start your journey as a machine learning or data scientist, because before that it comes with data, and data needs to be collected, data needs to be managed, and this has been all done in clouds and using SQL servers and other databases. So this is the data engineering part in machine learning. After that, you do the data science thing. What does it do? The must requirement for a data scientist is business understanding. So if you are trying to make a model which can predict something using some data, but then you find out even though I am predicting that thing or doing anything using that model, it's not actually giving my company or me some money or like some time or speed growth, anything that is giving business a good opening for using your model. So this is the best requirement a data scientist should have, that he should understand business understanding. So one should know some finances, how company work, what kind of thing a person should do as a data scientist to actually improve the business of your company, instead of doing just some random time waste on 2-3 months and finally finishing it with the project that won't be that good for the company also. So a data business understanding is the must. Once a data scientist has the data, the first thing you do is data cleaning. So generally in real life world, you will see not like a Kaggle case scenario where you will just click and download the data and it's done, and you will start working with the modeling thing and all. It does not work in the real world like that. You will use 60 to 70% of your whole project time in just data cleaning and preparation, just that. And then you will do some analysis after your training that how it is working, and then you do the same thing again and retrain the data model. So this is how generally a data scientist works in a complete project environment. So they gather the data from multiple sources and apply machine learning, predictive analytics, and sentimental analysis to extract critical information from the collected data sets. Understand from a business point of view, he can actually provide models that give accurate prediction and insight that can actually use to power critical business decisions. This is a very important step. If you become a data scientist and you are not doing this, your company may or may not fire you depending upon how much money you are getting. This is a very general case. This happens a lot. So one should know the business understanding in terms of data science projects. So the data scientist using mathematical algorithms, advantages, and business understanding train a machine learning model and then delivers production deployment models accuracy. So the accuracy should be so high enough that the company who is going to use that model is not losing anything in terms of if your model is making errors or making wrong predictions, false negative, or anything else. So for that, one should have a good mathematical algorithm skills and then business understanding. And after that, one should also know by you doing the analysis that how much accuracy is needed in your data science project for that particular company. If you are not doing that much level of accuracy, then it's not worth it to invest your months of time in finishing a project which won't be able to give that good accuracy. But it's also not like if it is not giving good accuracy, you just leave it in 1 day or 1 week. You keep doing it, try to do your max, and you have to decide like whether now it cannot be improved on, or it can be improved. You have to make this decision. So in short, a data scientist solves business problem using data driven algorithms and machine learning, often with extensive knowledge of statistics and mathematics, looking for trends and pattern in data to take the interest of the company to the next level. So this should be a basic architecture for a data scientist in many of the companies. And after that, one has to somehow learn how to deploy your model. So it is not that needed thing as a student, but if a student knows this thing, it's a very plus point. So how does a model deployment work? So what does a machine learning engineer is? So machine learning engineer are actually responsible for designing machine learning systems, which involves accessing and organizing data, executing tests and experiments, and generally monitoring and optimizing machine learning processes to help develop strong performing machine learning systems. So in general, machine learning engineer also handles retraining of data automatically, where the data is coming and where the data is going, where it is storing, this kind of stuff also. But in short, it is working after a data scientist it started working after a data scientist work is finished. Once a data scientist gives the model to the engineer, he make the model cycle complete, and then he deploys it on an API. And it also checks the request format, like what kind of format is required, HTTP request format for the API, and will do the load testing also. Like if the API is being used by many users in one time, how many users in per second or per request this your API can handle. So this kind of thing one has to know at least, and look forward to build their understanding for the model development. And then finally it will create a front end for the project, like an app or a web page, or if you are working with, if you have done some robotics, you know Raspberry Pi. So it's a small chip, and you can load your very small model, which Sagar told you, like you need to be very precise and very low in memory for your model. The more heavier model you are using, the less futureable it is going to be. People are going to make it very small. So Raspberry Pi, you can just load few MBs of model, just few MBs, and this works very nicely. So this is the end thing, completely end thing. So end-to-end project cycle will be data gathering, data cleaning, feature selection, then training, and then finally project deployment. Once this is all done, then you can look forward to build some other projects which you can find interesting in your this current project life cycle. You found, so you were reading different things, you came to know different algorithms, you came to know different machine learning uh, knowledge or anything else. And then what you do is you try to find another project. It's good to do Kaggle project, but it's not like you will be learning a lot from them in a real world scenario. If you want to learn from a real world scenario, you should create your own project in your college as a free timer and try to finish at least 2-3 projects in the meanwhile before leaving from the college, so that you have enough understanding of how a machine learning engineer or how a data scientist or how a data engineer works, and how actually the industry work. So once this is all finished, I am like I'm going to tell you some other things, which is new technologies. So there are some other technologies which are also emerging. You have heard augmented reality before, blockchains, it's limelight right now, robotics, 3D printing, virtual reality. There are all some new technologies emerging in the world, and we can actually start using these technology and start learning these technology, because in next 5 to 10 years these things are going to rule. So what right now data scientists are, in next 10 years maybe a blockchain developer will be. And anyway, blockchain developer are getting a lot more money than data scientists do. So these all the things, blockchain developing is a very different thing. Blockchain is a distributed database or a ledger that is shared among the nodes of a computer network. So unlike our government or any other thing which are handling all the things with paper, Excel sheets and everything else, this is the whole database network where we are storing nodes to all the open computer networks. As the database, a blockchain stores information electronically in digital format. The innovation with the blockchain is that it guarantees the fidelity and security of a record of data and generates trust without the need of a trusted third party, because all the nodes are connected with in a computer network. So any person who has that node can see the data and validate it, and after that, that once the validation is done, the data will be logged, so nobody can delete that data. So major key difference between a typical database and a blockchain is how the data is structured. A blockchain collects information together in groups known as blocks that hold sets of information. Blocks have certain storage capacity, and when filled and are closed, linked to a previously filled block. So it's like a linked list which is connecting one by one, but each block is fixed and locked, and you cannot form any other kind of thing in that locked block. It's completely locked. And this is how it is chaining a form of blocks. That is why it's called a blockchain. And blockchain are best known for their crucial role in cryptocurrency system as a Bitcoin for maintaining a secure and decentralized record of transactions, because all the transactions are in computer nodes, stored, validated, and then chained with other blocks, and it is keep on doing as many transactions are going on. So we always have the record. So this is why it is decentralized record, and this is a major innovation in the current world. People are looking at it. In blockchain also, actually, how does it works? Like, the goal of blockchain is to allow digital information to be recorded and distributed, but not edited. Make sure. In this way, a blockchain is the foundation for immutable ledgers or records of transactions that cannot be altered, deleted, or destroyed. That is why blockchain are also known as distributed ledger technology. How does it work? A new transaction is entered. The transaction is then transmitted to a network of peer-to-peer connection, which you all know with torrent, what is a peer-to-peer connection is, or at least heard of. So computer scattered across the world. So this is how it is being done. It is being traveled across peer-to-peer network. And once this network of computer then solves equation to confirm the validity of the transaction. So this is the mathematical algorithms that are running on inside it. So it's not like you can do something with it. Just for an example, of there is a fixed amount of Bitcoin that is going to be mined. Why? Because the algorithm is formed like that only this number of Bitcoin can be mined, this number of variables can be solved. And if that is the case, there is no way even a single Bitcoin after all the Bitcoin has been mined can be mined more. So this is why this is the thing, that how the network this network of computer then solves the equation and confirms the validity of the transaction. Once confirmed legitimate transaction, they cluster together into blocks, and these blocks are chained, and then the transaction is complete. So this is how a kind of a blockchain system works. And there are actually n number of blockchain applications. So I have like made list of 13 14 NFT marketplace, which is like very in limelight right now. Cryptocurrency exchanges, yes, this is a current thing in India. You have heard BitBNS, WazirX, and all these other things on watching IPL and seeing the ads of it. And there are all the other things: real-time Internet of Things operating system, personal identity security, anti-money laundering tracking system, supply chain and logistic monitoring, voting mechanism. So these all things can be solved in a blockchain environment, and a developer can look to understand this kind of technology also in college time, so that once they are at their graduation and after that they are looking to change something into a blockchain world, they can do it as they have some good information. And anyway, blockchain is going like it's going to work in next 5 to 10 years a lot more than what is going to be working now. So this is all about blockchains and emerging technologies in current industry. Mostly it is ML, but right now blockchain are competing against ML and coming forward as a key major factor in new technologies. So after that, I think what's the time? Yeah, I think I have a surprise for you. Wait, let me check whether it is available. Yeah, so I have two very good friend of mine from the same 2018 batch from say IIT Kharagpur, and like is it there? Yeah, I'm just making up your surprise. So I have found it. So I have Kunal here, and I think I have Srinidhi also. Yeah, Srinidhi is also here. So hi, both. Hi to all of you. Both of them are my classmates, and are you available? Can you like open your video, Kunal?
Hello. Yeah. Hi, Abhishek. Yeah.
Yeah. Hi, Kunal. How are you?
Yeah. Doing really nice.
Yeah. Okay.
Shri is
So
also here. Yeah. He's coming in a minute, I think. Yeah.
okay. So let me introduce Kunal. Kunal is my friend who is currently working in River Space. He's founded this company last year, and now he's looking forward to do some good metaverse thing in his company. So I'll let him know what his company doing and how it is working.
Yeah. Sure. So, hi everyone. I'm Kunal, and so I founded last year a company called Revert Space, and I'm a graduate from IIT Kharagpur only, 2018 batch. So we are making a 2D gamified metaverse for communities and organizations to connect better. As you can see right now, the whole communication is happening on Zoom or Google Meet kind of platform, where the communication is one to many. The rest of the people like you guys right now can only hear. You cannot talk to each other and engage and network. So what we are building is a platform so that each and every one of us will have our own avatar, and they can form into groups. If you guys want to form a group, you can easily do it and listen to the speaker who is talking to you guys. So the whole social dynamics part of real life can be done in virtual. The personalized learning, engagement, connecting with each other, that can happen. So yeah.
Yeah. So Shri is also here. Can you hear me?
Yeah,
Yeah.
I
Hi,
can hear you guys.
can you turn your camera on, please?
Yeah,
Yeah,
it's on.
my camera is on right now.
Yeah.
Okay.
I'm not sure if I'm pinned to the screen. So hi guys, this is Srinidhi here.
Yeah.
Uh,
So Shri, let me introduce Shri also. Shri is also my batchmate from computer science department. He has worked in various industries and now he has started his crypto world flippy finance startup. So he's making like social media kind of thing with crypto, and I'll let him talk and about his project.
yeah, thanks, man. So what we're doing is you guys must have heard of small case. So we're building small case for crypto. So it's an investment discovery platform. That's what Flippy is. So every new investor is getting started with crypto investment journey, right? If you got started sometime last year, you must know about the mental barrier that crypto investment gets you through. So that's primarily the problem that we're looking to solve for. We're making sure that every new investor is getting into the crypto ecosystem knows when to invest, where to invest, and knows the best practices to going about investing into cryptocurrencies. So that's primarily what we do as a product. And yeah, so Flippy is like a fun to use app. You can actually go check out Flipstory, which is our newsletter, and you'll get like 3 memes every day into your inbox. And that's how we're going about building out like a crypto platform, not a serious finance or like a tech company, but rather rather a platform that you can relate to and get started with for your crypto investment journey.
Yeah. So like, is your platform is available for trading also, like, or is this just a social media right now?
Right. So you can actually put in your investments through Flippy right now. The way we go about getting you to invest is kind of unique and offbeat because we do understand that crypto investment is a community-driven activity, and it's not something that people are doing in isolation, right? It's not something that people are doing alone in silos. It's something that it's an activity which people are using different communities for. They're on Discord. Some of you guys must be having like WhatsApp group chats, or like even a friend that you refer to, right? Ki bhai kahan lagana hai, bata de types. So that's primarily the community-driven behavior that we're seeing in crypto investments. So that's something that we baked into the platform, but at the end of the day, it's an investment platform. So you can come onto the platform, you can invest through your traditional workflows, but all of the offbeat workflows that you have, that you usually have when you go about investing, that you juggle between 5 different apps for. All of those things, all of those workflows is something that you can get in a simplified manner on Flippy, because you can basically connect with friends, check out public portfolios of users, and even follow your favorite crypto influencer on the platform, right? So all of this is baked right into the platform, along with the transactional activity or the trading activity that you would traditionally expect.
Okay. Because what I remember initially, it was all about, when it was not even started, it was all about news about crypto, what you should know, what a layman man does not know at all in blockchain. You were giving all those information even before starting all this thing as the Instagram stories and all. I was following all these things.
Right. Right. So I guess like I think Kunal would also relate to this, right? So whenever you're starting up something, you exactly don't know what product you want to build, but you always have an affinity towards the problem that you want to solve, right? The product takes shape over like 2, 3, 4, even 10 years, right? Even if you look at how Coinbase started out, they started out as a Visa, or like a Visa for cryptocurrencies, right? So if anybody wants to accept payment in crypto, they could just use Coinbase APIs to build it. But right now, Coinbase is like the biggest consumer platform for crypto investments. That's a product that has taken shape over multiple years. But the problem that they're trying to solve is trying to make crypto accessible to everyone. They're still true to that problem. They're still true to that ethos of what they built that initial founding team for. So that's kind of the journey that I've been focusing on. I think Kunal has been focusing on that as well.
This makes me ask you a question, like for both of you. First, Kunal, like when and why did you transfer or change your job life to like 9 to 5 job life to your started your own startup? Like when did it start? How does it start?
Yeah. So since college, I think Shri and both of us, we used to talk about having our own startup, and used to bounce off some ideas. We can work on this and that. And after 18, I was working as a data scientist at Walmart. So after having 2 years of experience, I got a glimpse of the corporate side, how things are happening, how things work around, and like that. And I think in 2020 January, I got the idea first about starting a parking startup. So living in Bangalore, as everyone knows, how crowded it is. So I thought about like having an app so that people can book the parking slot easily. But then COVID hit. So after COVID hit, I realized that there are no cars on road right now. So you cannot make a parking startup at that time. So, but things happen and you realize and you iterate. That's the most important part, I think, of building a startup. You iterate, execute, iterate, and change. So then So Walmart, then I switched my company, another company, it's called LucidWorks. So it was a remote company. The main office was in USA and my team was in London, India, and US. So the thing that I realized was the whole working environment was related to just work. There was no talk about our personal life or anything yet. I wasn't able to make personal connect with the people I'm working with. And that was happening just because we are working in remote company. So me and my co-founder, we thought about this, and he was also working in a remote startup. So then we start thinking how we can make the whole experience better. So that's how the word came in, and we built on this idea, and we are following this dialogue even right now to make the virtual better place for people to connect with. And if you tell you that,
like what your startup can do, we can have this whole meeting in your startup.
We should have I think from the next time, if you guys are having this meeting, it should happen on Revert Metaverse, where people can actually enjoy a lot more.
I have seen you can play some games also in your startup, like like you can play in your real office. You just go there, you can start playing and all these other things. So it's a kind of good addition.
So we are making the whole ecosystem. Right now we are building a web app so that people can come there to connect with people easily. They don't have to schedule any meeting. The whole hustle of scheduling meeting is gone now. If I want to talk to Shri, I just move my avatar close to Shri and our audio video call will end. We have integrating tools like Whiteboard and embedded links. So if people we have these on Prime, like watch parties, watch parties. If you want to watch a movie with 2-3 people or your friends, you can just enter the watch party. And the whole dialogue is you will be seeing the movie and they will open a text box. So there you can text. That's not normal. That's not how you watch a movie with your colleagues, right? With your peers. So what we are doing is we are giving a functionality called embedded links. So after embedded links, you can open other website inside our Revert platform only. So if I wanted to watch Netflix, I can just open it there and everyone will be able to talk to each other and watch it. YouTube videos, Spotify, anything. Any part can be done. And similar to those are the productivity tools like Slack, Trello, Microsoft Teams. Anything can be opened over there. And games part is also there because there are a lot of virtual communities which have async communication, asynchronous communication like on Discord. But there is no concept of a social adda that exists like a persistent space for those communities to actually come and interact with each other. So we are working on that part also. So that companies can come to that social adda and find people over there. They will be there, they can interact and gel up and make new connect. Then Gen Z is after it. So we are making sure we bring the people together.
So you are making sure all the generations can come along in all the things they do. Like I remember playing Counter-Strike and all and having chat in phone and all these things. So having 2-3 skins handling at the same time screens, not a good thing. Cool. And same goes for like Shri also. Like what was your journey? How did you chose your software development life behind and wanted to become a CEO of a company? How does it happen?
So I don't think it was like something that I had planned for, but so this is something that I was always interested in. Crypto is something that I was always invested in, not as something that I wanted to pursue a career in, but something that actually fascinated me for quite some time now. So that fascination was there when I was in college. Also became like a user of crypto in multiple ways and a contributor to the ecosystem in multiple ways. But at the end of the day, it was not something that I was choosing to pursue a career in. And primarily what happened was I joined American Express as a research analyst, and I saw like the world's biggest fintech product, or like the fintech company. They do not have like a blockchain research team. So I started doing small research sessions, which we used to call, whatever we used to call them. So this was primarily to disseminate your learnings and basically to get people excited about new things. I started out a small session for my fellow analysts, and that kind of sparked a bigger blockchain research, kind of like a movement within the organization. So multiple leaders started joining it, and they actually started looking at it. So that's when I realized, this is something that there's a very big barrier of entry into crypto, not just for users, both for institutions as well as, not just for institutions, both for institutions as well as users, because for most people trying to get into crypto, it's the financial aspect of investing is a mental barrier that you obviously have to cross. Because people find it hard to get started with investments. Doesn't matter if it's gold, real estate, equity, mutual funds, or crypto. At the same time, the fact that it's an entirely technology-driven investment asset class, a lot of it is algorithmic, and a lot of it is something that's beyond the understanding of an average investor who doesn't even know or care about how to price or value a company, right? So these are all the mental barriers that existed for people to get into crypto. And obviously, the on-ramp is the most important process of the Web3 movement. Like, you can only access like Web3 platforms if you're a holder of a particular token. You can only access, let's say, the Ethereum blockchain, or you can interact with Ethereum blockchain if you hold Ethereum, Ether in your wallet. And same goes for multiple other Web3 platforms. I realized that the biggest problem to solve for over here is to try and on-ramp as many users as possible and make sure that they're getting access, easy and relatable access into crypto. So that was how it started. I initially started off as something like a micro investment platform where every time you carry out a transaction, the idea was to round it off to the nearest whole number, right? If you spend 25 rupees, round it off to 30 rupees, invest the 5 rupees into crypto. So it started off there, kind of reached late stages of execution. And then people started telling me, hey, you know what? I don't want to invest like 5 rupees. I want to invest like 1,000 rupees. And these were people from tier 2, tier 3 cities telling me they want to invest in upwards of 5,000 rupees. So this idea kind of became obsolete in just like a couple of weeks. So that's when I started thinking more and more about, like, what can you help users do? So thematic investments was something that I related to a lot. I talked to a lot of users. They started discovering investment opportunities through themes, right? So when I asked them, like, do you think NFTs are going to be huge? They say yes. But when I ask them, have you taken a bet in the ecosystem? They say no, primarily because they think they have to invest like hundreds of thousands of dollars. So I just created like a simple NFT basket with like 3 projects that are building NFT platforms, and anybody could get exposure to NFT basket with in $1,000.
Okay.
So literally every single user who invested in that basket had not heard of those tokens individually. They didn't know what Decentraland was. They didn't know what Engine was. They didn't know what Chiliz was. But they knew they wanted to invest into the NFT infrastructure or like NFT ecosystem. So that was like my eureka moment, saying like, hey, there's a business to be built in investment discovery, and there's a value to be added over here, right? Which in turn will lead to a business to be built. So that's how Flippy came to be. Flippy took form in the way it has right now. So right now our focus is primarily towards enabling investment discovery. So all of the ways in which you discover investments will be baked into the platform sooner or later.
Okay, so in short, if I ask you, like, if a student wants to start a startup, it's not like he's thinking like, I have to start a startup. He just move his journey along. He start doing work. He see the industry. He just get to know things, what is going on, what is the need of the current hour, and whether that need is like decent enough or is just a very small need, and then look forward to start their journey. And then in the journey itself, you will find out, okay, these are the things I can do more. So instead of just having a rigid plan, like I want to do this, it's better to go with the flow, like what the current world is asking for it. If you want to make a good startup which will be getting funded and which will be, people will be using it, there will be users, and it's keep on increasing, not decreasing with every possible quarters or like years. If you are going for make something like this, it should be go with the flow, or like you should have a very rigid mindset, like I want to make this since your college time, and then you after the college start doing this only. And like,
right. So I think the way I would put it is you need to have like a very strong understanding of the world around you, at least for you to even start, even for you to get that confidence of wanting to start up, right? Because there are multiple things that you have to put into place. And some of them are solvable problems, some of them are unsolvable problems. So you need to have the maturity to understand like which are the problems that I can solve immediately, which are the problems that I have to figure out along the way, that I have to be comfortable with not knowing the answers to. A simple example would be like, in my case, the regulatory aspect of it is something that even if I work my ass off, there's nothing I can do. I can't change the regulatory scenario or like the regulatory aspect or even the taxation aspect of crypto that the government is taking. All I can do is I can react to it. I can react fast. I can build fast, and I can iterate fast on these macro changes. So that's something that you need to have as an ability and as a skill. If you have that while you're in college, if you're able to build that while you're in college, then good for you. Like, that's awesome. You can get started while you're in college. If you take like a couple of years, that's also awesome. So I don't think there is like a time-bound aspect to gaining those skills or getting those insights. At the same time, you learn a lot of things on the job. I think Kunal will have a lot more concrete thoughts on this than I do, because he essentially started iterating much before I did, like even on the previous idea that he talked about.
Can Kunal, you want to add something?
Yeah, sure. So in things like this now, what I believe is iteration is an execution. That's the main essence of doing a startup. Because what happens is when we thought about, there was one more idea, I'm not able to remember. So it was something in like architecture we were thinking. Like the planning, the making the architecture map of the layout of the entire space. We were thinking of making it using data science. So automatically we are able to make it. Okay. But when you enter into the problem, you start thinking, is it even possible? So that's when you realize that I won't be able to do this.
Yeah.
Right. So always, if you have any idea, just try to execute 5% of it. You will get an essence of what things are working and what things are not.
Yeah.
Like to give you even a more simple example, like with Revert Space, we thought remote offices is our biggest market. But after talking to like 50 or 100 customers from India, we realized India doesn't care about that much about feelings or connectivity. The main focus is towards work. That's like the Indian company's mindset. Little bit, we can say, in US, it is different. They care about their employees' welfare and all. The main priority is that. So now in India, we have to think of another market, right? At tech space, mein hum kar sakte hain. And what space the market is going to give us good returns? Who will be our early adopters? So always execute. You will understand that, okay, this thing is working, this thing is not working, and take risk, basically. And think about it and just go forward with it. You will be able to solve one or two problems. And you will find a use case. You will change your startup. Kuch na kuch iterate karke, you will find a solution. That's what I believe. Yeah.
So like going forward, like knowing all the other things is a better approach. Keep on researching. Even starting today, you keep on researching, Googling. Don't waste much time on social media. Instead of learn how to improve social media or any other thing, like think productively instead of like getting entertained. Like, okay. Cool.
I believe one more part, that like researching also. So market study, you'll keep on doing it. That's also easy part. But executing is a difficult part. Just start executing it.
Yeah.
Within 10 days, 20 days, you will get a basic essence that these things are working, these things are not working. So I should iterate and change my startup, basically.
Okay. Cool.
That's it.
Yeah. So this one thing from you also, from you only, like you are working with metaverse, and I have also huge interest in crypto and metaverse and everything else. So I am looking forward in next 5 years. What do you think metaverse will be, or what kind of innovation will be there in metaverse in next 5 years?
So one thing I believe it's going to be a more integral part of our society going like 5 to 10 years. And like from the hardware side, I think VR headset are going to get lighter and more comfortable so that people are able to wear them. Because right now there are many like 3D worlds like Decentraland, a lot Fortnite and gaming industry a lot, but those are computationally heavy. So our computers need to be the processor need to advance a lot more than that. And VR you should be able to wear headset for like 1 or 2 hours or 3 hours. But right now, after 10 minutes, you get that hangover kind of a feel. So that part is there. And the next part, the most important part, is the social dynamics. So right now, the whole interaction is audio and video that we have is one-to-many communication. with metaverse, the whole social dynamics is going to change. Each and every one of us will have our own avatar, where we can change the skin, make it dress up like that movie, Ready Player One.
Yeah.
In some kind of it, that aspect is going to come into our life where people are able to make friends, do dating stuff, and everything is going to go into virtual a lot more than before.
Yeah.
Because the new generation are born with phones and all these kind of platforms, so they love to talk to people in virtual, and that's how things are going to evolve more.
Yeah.
But to make any a good thing also, like we have to make sure that personal touch has to be there. People should go out and play more, and that aspect people should do. Because if we went too much into the virtual part, then that part is going to go away.
Okay, so there is a mixed thing, like technology-wise, there can be a huge advancement, but other than that, humanity and like our emotions and behavior, we need to see how things will, like how people will react to these kind of technological changes. And you also added this VR thing. So just before this, Sagar was presenting, and Sagar was telling the same thing, like how VR is going to make all the things possible in the world, and how computer graphics and all is kind of making things possible. For smaller headset, you will be able to wear for hours with very less memory used by it. So already we are moving towards the technology. It's just about how human will keep with this technological change, right?
Yeah.
Okay.
Yeah, that part is there. I think Facebook is also researching on haptic responses with the VR headset. So basically, you will be able to feel things on your fingers and everything. So the whole aspect of virtual reality is going to get more immersive day by day.
Okay. I have read a news yesterday only that a guy is asking a very good celebrity in metaverse only to be present in the wedding. The wedding also happened in metaverse. Days back. It was a very costly wedding, and also people are already getting into technology and try to get their past associated with it. They're very important memories associated with it. Like a marriage is a big thing, and they are moving towards metaverse. So it kind of gives a good positive response. The same thing, if I ask Srinidhi, what do you think about blockchain in next 5 years? Or I would say for you, it's till 2030. What do you think blockchain is going to be till 2030? If you have any sights of that, or you can tell me in your near 1-2 year future only.
See, one thing I think blockchain will be visualized as is right now it's massively associated with crypto, but I think we need to dissociate with that fact and think of blockchain as a decentralized network, right? So I think of blockchain as an open AWS or an open Google Cloud, where you don't need to create an account, link your PAN and Aadhaar or debit card to essentially interact with a data center. You can essentially pay in the native currency on the Ethereum blockchain, it's Ether. On the Solana blockchain, it's Sol. On the Cardano blockchain, it's ADA. So, I think that's a better way to look at it, and that gives you with a mental model to think of what next, right? So, what I believe would happen next is we are going to move away from like coupled platforms like Facebook and Facebook data center, Twitter and Twitter data center, Instagram and Instagram data center. I think that's going to be dissociated over time, and what we'll look at is primarily platforms like Revert might stand to win a lot from something like this, right? Because what will matter more is what are you going to scrape, what kind of data are you going to pull out of blockchain and present on your front end, rather than what kind of a coupled platform you can build, right? So right now, if you look at it, people want all of their data to be present on one single place, which is be it their iCloud or be it their Instagram or be it their Snapchat or wherever it is. And what we'll see more of is platforms encouraging people to upload their data onto blockchain and then serving as an interface for that data, rather than taking the responsibility of both hosting the data and serving the data to the users. Because when you do that, you kind of compounding your problem of also having to regulate the kind of data that is being circulated on the platform. which is sort of like data policies, privacy policies, and restrictions, right? Platform restrictions are pretty much become unsolvable, and they're eating up these platforms like cancer. Platforms like Twitter, Facebook, and even Instagram, for that matter, are notorious for hate speech and notorious for removing content that are subjectively termed as hate speech or offensive content, right? So this is something that will become more and more prominent over the next couple of years, and blockchain will solve that problem primarily by decoupling these platforms with the data, and only serve as a front end for the blockchain rather than being the host of the data by owning the blockchain as well. That's what I think. But although I think I could be completely wrong, and this might be the stupidest thing ever if you hear 10 years later. So don't quote me on it.
Sure. So just I wanted to have a quick lookout for you, like how it is going to be in next few years. But I have also seen this, the Pranay, he's working in Tencent.ai. He's started a startup, and this workshop is all about that only. So making arts from AI, you can make artificial images, you can make all kind of data. So I don't think Flippy can do something, but can Revert use that kind of AI technology where you are creating random arts to place that art in your system background, or that kind of thing? Like you can make that AI art inside your this framework, and people can have, instead of solid colors, they can see very nice art forms associated with the same company, or you are giving information how you are going to make that art photo. So people are going to give some information, and they wanted the art to be like that. So that information is related to the company. So can be used, or like?
Yeah, so I think one part will be the hosting art galleries. That's something that can happen pretty easily, and it's already happening at multiple platforms. The second is like creating art from text, right? You're writing something and you're able to create that art. Is it?
Yeah,
so that part can be, I think that part can be used in like avatar skins and all this kind of stuff.
Okay.
Right. If I want to change the layout of my space, because we are giving one feature in Revert is called a builder, so that customers themselves are able to customize their space, add any personalized stuff that they want to add. Like on a table, they want to add flowers, something to make it personalized. So that part can be used, I think, in that sense. If they want to, like, they write anything, customize the space according to my need, and it's able to, the AI is able to do that. That part can be done.
Like a small question from for both of you, like how a student can guide themselves into this very risky blockchain world. So can you give some advice as an experienced guy, like how a student can dive into this world?
So I'll go first. Just don't start up. Just try as hard as you can to not be an entrepreneur, because it's one of the toughest things that you'll do, and you're better off not doing this, right? You live a more comfortable and happy life. But if you come across a problem that you feel extremely passionate about, and you kind of, everything else becomes less exciting when you think of pursuing or solving a particular problem, only then you can start up. So until and unless you have that kind of conviction and that kind of like drive and hunger to solve a particular problem, just don't do it. And once you have that, there's no other option. So like if entrepreneurship is an option, then it's probably not a good option to you, right? So only when it's not an option, that's when you should think of starting up.
That seems like a good advice. For you, if you want to give something good.
So I think little bit different from it. I think till 30 you are young. Just go on about it. Don't go after the money and do something. You will learn so much more than you can learn in a job. That part is so true. Because you will be, in a simple sense, if you're doing a particular job, you are learning one aspect of a company. Like I was in data science, so I was interacting with the product team and learning about the stuff in data science and everything. But when you do a startup, you start interacting with your product team, data science, or like data analytics team. your UI team, UI UX part, design team, marketing team, sales team, HR team. So you will get an aspect of the whole organization. So that part is really nice because you after you will know what you want to do.
Yeah,
that part is good because after like 2 years I was interested in data science. Now I enjoy the marketing part also. Marketing is kind of really fun.
Yeah.
We are able to experiment, put some ads and things, and the conversion rate turns up really huge. So that part is also fun. We are able to think how people are thinking about your product. So that's I think that part is interesting if you want to go on about that, where you will able to learn all about different industries and fields.
It's kind of a hunger. If you want, then only you go for it. Otherwise, like Srinidhi told, like if it is an option, leave the option behind. Okay.
No,
Yeah,
I kind of agree with Kunal over here. So definitely this is one of the most fulfilling things to do. But what I've also seen is a lot of people with not a lot of conviction try to start up and they fail, and they kind of have like a very bad experience very early on. So for you to get through that barrier, I think you have to go in with a lot of passion and a lot of conviction. So if that is not there, I think you'll not be able to enjoy the things that Kunal is mentioning. So you'll kind of get bored and get kind of dejected very soon, and it's kind of
it's like so in short, like my friends, you and you, both of you are like making startup, and if I start to think, oh, I should also make a startup, this is a very bad idea, right? Just for the
it depends. If you, I think if you jam with us enough, I think you might get excited enough to pursue it.
Okay.
No, there are numerous ideas. Any ideas you can find anywhere. The main thing is start doing it. Yeah. That's the part.
That's all, I guess. From it's already a lot of time. Thanks a lot, guys, for this short notice you appeared. Thanks a lot, and bye bye. And I am also finishing this. I'm handing it to Karthik, I guess.
Just before I leave, guys, check out Flippy. It's available on both Play Store and App Store. And if you're interested in joining the team, feel free to reach out to me on LinkedIn.
Yeah.
Have a great weekend.
Yeah. Same here. Bye everyone. Yeah, it's Kunal. And if you want to directly contact me on LinkedIn, if you guys looking for a job, because we are right now hiring interns, a lot of interns for 6 months. So yeah. Inshallah. See you.
Okay.
Bye.
Okay.
Thanks.
Thank you. Yep.
Thanks,
thank you. Yeah, thank you, Kunal and Srinidhi. The ideas for the startups were really intriguing, and also we say fun day, right, in KGP, like fun day for the people who are aiming for startups and all. It would be a great for them. And also special thanks to Abhishek. Like presentation was great. I think so. Most of the viewers are still in first year or second year, so they will get a good idea of how to start a project from scratch and see it till the end. So yeah, presentation was also great. So if anyone has any questions on the presentation, then please go ahead. Or yep. Okay, cool. So I don't see there are any more questions.
Sure.
So thank you, Abhishek, and not only Abhishek, like all the speakers, especially Pranay, who made this workshop happen, and all the speakers who gave their time for spreading the machine learning and AI and the art, how to generate art using ML to the KGP community. We thank you on the behalf of KDAG and also the KGP community. So yeah, about that. And one more announcement, like some of the people who are aiming to, some of the people who want to take, who are already participating in ML art competition. Today is the deadline for it. So please submit the art till tonight. I guess it's till 12 AM, I guess. So that was about it. So I think so we can conclude the session now. Yeah, thank you, everyone.